anyone. And second is I mean network who can manage that um, networks and apply the protocols and all. And
Yes, correct. So the list I have yesterday I have clearly mentioned, right? The top first one is network interface card, media, networking
NIC.
devices, IP address, and protocols. NIC has two addresses. One is MAC address and IP address. And NIC types. What are the types of NIC?
So basically three types. That is a 100 Mbps, 10 Mbps, and 1 gigabyte port.
NIC types are Ethernet, fast Ethernet, gigabit Ethernet. So Ethernet can support up to 10 Mbps. Fast Ethernet 100 Mbps.
100
Gigabit Ethernet
Mbps.
1000 Mbps or 1 Gbps. And media, two categories, wide and wireless. In wide RJ45 cables we discussed. RJ45, different type of connectivities. Where to use straight cable, where to use cross cable.
So same device we can use cross cable. Different devices we can use straight cables.
Okay. And next we started discussing about networking devices like switch, access point, router, and firewall. So what is the purpose we have to use switch? For what purpose you have to use switch?
So to connect the multiple devices with that same network, then we can use the switch.
For wide devices, switch. This is main point actually, wide devices.
Yes, I'm right.
Then when to use wireless access point?
We have
Wi-Fi
wireless.
devices for the
For wireless devices
Yes,
Wireless devices.
and wide devices.
for both.
When to use router?
to connect the different
To
networks.
access other branch.
Two or more different networks. Then when to use firewall?
Apply the security and to protect the network.
Yes. So to control unauthorized traffic, to filter traffic, firewall. So today I'll continue with next requirement, which is IP address, logical address. So today I'll focus on IPv4. Basically, IP address are two versions, IPv4 and IPv6. IP address, two versions. One is IPv4 and IPv6. So currently we are working with IPv4. We are getting communication with IPv4. IPv6 for next generation. We are slowly migrating to IPv6, not completely. So we require more knowledge on IPv4. IPv4 is 32 bits. It's combination of 0 and 1s. Let me take one combination of 0 and 1s. 32 bits we need to write. So I'm taking some just random numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Okay? So this is one IPv4 address actually. So this entire IPv4 address, the format is it is in binary format. All 32-bit address is divided into 4 portions. like first 8 bits, second 8 bits, third 8 bits, fourth 8 bits. Like each portion technically we called octet. So one octet must contain 8 bits. Like IPv4 is divided into 4 octets.
32 bits.
4 octets are
32.
32 bits. Right. So every octet. So which is the first octet, second octet, third octet? How can differentiate? By using a dot. First octet dot, second octet dot, third octet dot. But this long ways, this format is binary, but as a user, how we can understand when to convert into decimal format. So to convert from binary to decimal, we can take 2 power n value. A 2 power n can be 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, 2 power 7. Like one octet contain how many bits? 8 bits.
8 bits.
So the first one, second one, 3, 4, 5, 6, 7, 8 bits. 8 bits is enough actually. Any power value, any power 0 is 1,
1.
2, 4, 8, 16, 32, 64,
120.
128. So here, the first bit value is 128, so 64, 32, 16, 8, 4, 2, 1. Like second octet, same. 128, 64, 32, 16, 8, 4, 2, 1. So logic is 0 indicates 1 indicates. 0 indicates a bit is off bit. 1 indicates a bit is in on bit. 0 indicates off, 1 indicates on. So in first octet, which bits are on bits? 16 is on, 8 is on, 2 is on. Now if you total these on values, 8 plus 2, 10 plus 16, 26. So first octet value in decimal is 26. In binary, 0, 0, 0, 1, 1, 0, 1, 0 like this. But in decimal, simply can write as 26. Similarly, second octet. In second octet, which bits are on bits? 32 is on, 16 is on, 4 is on, 16 plus 4, 20 plus 32,
52.
52. So second octet value is 52. Similarly, you try to quickly calculate and tell me the answers for third octet and fourth octet.
68.
36. The third one.
So here 32 is on, 4 is on,
36.
36. Next, 8,
14.
8 is on, 4 is on, 2 is on, 14.
14.
So we got one IP address now, 26.52.36.14. So this is how we can convert from binary to decimal. So I need a few examples IP address. Tell me few list of IP addresses. Just a minute.
10.1 dot 10.0.0.1 to 256 or 254 or 255 class A 192 168 0.2 0.1. We can take number of series to up to 254.
Yeah, let me take this example first, which is 26.52.36.14. Yeah, sorry, I didn't hear you. Can you repeat? Like, I need a big list of IP address. Everyone,
Sir,
please give me your own example. One IP address. Everyone give one IP address.
Sir,
one
Yeah,
192 dot
100.92 dot.
1
Oh,
dot
you are telling is 192, right? 192
yeah,
dot
16.1 3 dot 0
16 dot
3
3 dot
dot 1.
3 dot 1. Right, thank you.
Yeah.
Next.
10.0.0
10 0 0 0
27
27. Next.
192,
192
196, 168,
168
29.1.
29.1. Is it your computer IP right now?
No.
Oh, okay. Next. Everyone, please give me one address. 169.255.255.254. Okay, next. Okay, I'll give my examples like 200.234.1.48, 172.168.23.45, 10.122.122.0, 182.16.192.17. Okay. So I'm making some big list actually, okay? Uh, like 245, just some numbers I'm writing. No logic behind here. There's some number lists I'm writing actually. Okay, 12.68. So 224.9.6.192 and 201.234. Just some numbers I'm writing actually, okay? Enough. So we have learned how to convert from binary to decimal. But actually we should know total how many IPv4 addresses are available. So what is starting IPv4 address? What is the ending IPv4 address? What is the range of IPv4 address? You should know it. IP version 4 address range.
Equal
So
to
IPv4 address is how
255.
many bit address?
So from the 1 to 255.
No, no.
32,
Just
sir,
my question
32.
is how many bit address?
32.
32. Okay. So 32 bits, right?
Right, sir, bits.
32 bits. Bits means
Four.
combination of 0 and
Yeah,
1s.
0 and 1.
No voice.
Hello. Yes, I'm Farouk.
òṣìṣẹ́ mò ń lọ nẹ́tíwọ̀kì ẹ̀kùn tí wọ́n ti gbàjẹ́ ń bẹ̀rẹ̀. Hello? Hello?
Can hear you, sir. But I think the coordinator's network.
Yes.
I think sir mic is muted. Maybe he's got the call or something. I think we should wait.
Okay.
Àpẹẹkùn wọn ti jẹ́ ń bẹ̀rẹ̀ kí ló ń ṣẹlẹ̀ báyìí? Teacher ti lọ. Yá ìwọ ló máa lọ sùn tí ẹ àmọ́ nǹkan tó ń ṣe nẹ́tíwọ̀kù.
Yes, please. I am just 1 minute wait, please. Okay.
Yeah, okay, sir.
Yeah. So IPv4 address is 32-bit plus the combination of 0 and 1s. In 0 and 1, which is the least bit?
0.
0 is the least bit. Which is the highest bit?
1.
So if we take all 32 zeros, is the least IPv4 address, starting combination. And if we take all 32 ones, is the highest combination.
Yes, sir.
Agree?
Right, sir.
Right. So let us take a least combination first. Means 32 zeros. First octet least. 1, 2, 3, 4, 5, 6, 7, 8. Dot. First octet least.
Hmm.
Second octet least. Third octet least. And fourth octet. Okay. Highest
1, 1, 1.
1, 2, 3, 4, 5, 6, 7, 8. First octet highest. Second octet highest. Third octet. Fourth octet.
Yes.
So do you have any other combinations?
No, sir.
No.
255.
Minimum, high, minimum and maximum you have written, right?
Yeah, right.
So this is
sir.
the range of IPv4 address. So what is the starting range is like all bits are off. Means 128 is off, 68 is off, 32, 16, 8, 4, 2, 1. Like all are off. Means it's a 0 dot 0 dot 0 dot 0. And here all bits are on bits. Means 128 is on. 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. What is the value?
255.255.255.
Excellent. So all one's value will be 255 dot 255 dot 255 dot 255. So this is the range of IPv4 address. 0 dot 0 dot 0 dot 2 255 dot 255 dot 255 dot 255. In between we have 4.3 billion IPv4 addresses are available. So total IPv4 addresses are 4.3 billion IP addresses actually. Got it? The range of IPv4 address. Is all 4.3 billion IP addresses are classified into 5 classes.
Yes.
Like
Say class B, class.
class A address, class B, class C, class D, and class C.
Class C.
Why they classified? So each class we have different purpose action. Example, class A, B, C. This ABC classes IP addresses are reserved for local area network and wide area network. So within a room, if I have 100 devices, which class IP address we have to use?
Class C.
A, B, C.
Yeah, right.
Within a floor, we have thousands of devices. Like which class IP address we can use?
Class ABC.
A, B, C. Like within a building, we have like thousands of thousands of devices. Which class IP address we can use?
ABC.
A, B, C. Like branch office 1 here, branch office 2 in different location. Like in wide area network also, which class IP address we can use?
ABC only.
A, B, C. So class A, B, C IPs are reserved for LAN and WAN. Then what about class D? So class D IP address reserved for
Multicast.
multicast. Correct. Multicast purpose. And class E IPs are
R&D.
R&D, research and
Development.
development purpose. So here I have one doubt, guys. Doubt is before we have prepared some list of IP addresses, right? From this list, the very first one, 26.52.36.14. This IP address for what purpose I have to use? We can use for
Class.
LAN and WAN or multicast or R&D. For what purpose this IP address is reserved?
So LAN and WAN.
How we can say is LAN and WAN?
So class A belongs to class A IP.
So the thing is, first we need to identify. So IP addresses belongs to which class? Is it A or B or C or D or E? So today our first task is by seeing IP address, we should know, we should identify IP address belongs to which class. Agree?
Yes.
So how to identify means there are certain range for each class. So from 2, this is belongs to A. from 2. This belongs to class B. Like based upon the ranges, we can identify that is a class A or B or C. So what is the range of class A, guys?
0.90
0 to 127 class
127.
A.
120
For class B, 128 to
91. 191.
191. Okay. See, any IP address is starting with 0 to 127, this IP comes under class A. Any IP address starting with 128 to 191, IP comes under class B. All right. So similarly, you have certain range of C, D, E also. But my question is, what is the logic behind here for class A 0 to 127 only? Why not some other numbers? Why not 0 to 100, 0 to 90? So what is the logic of 0 to 127 only for A and 128 to 191? Why not 128 to 160 or 128 to 200? What is the logic? So how we can differentiate 128 to 191 only? What is the logic behind here is classification done based upon priority values, priority bits. So first octet, first bit, 0 is reserved for class A. First octet, first bit, 1 0. First octet, first 3 bits, 1 1 0 for class C. 1 1 1 0 for class E, 1 1 1 1. Based upon these priority bits, classification is done. And these priority bits are fixed, reserved. Okay, I'll explain it, okay? So these all priority bits are reserved from which octet? First octet.
Perfect.
So priority bit is used for IP address classification. Most significant bits from first octet are selected for priority bits. For class A, 0. For class B, 1 0. For class C, 1 1 0. So 0 means 1 bit. 1 0 means 1 0. There are 2 bits are reserved. Here 1 1 0. 3 bits are reserved. Here 1 1 1 0. Here 4 bits. Here 4 bits. Like this. So all priority bits are reserved from which octet? First octet. Let us take first octet value. What is the first octet value? First octet value, zeros and ones, correct?
Yes.
So same first octet I'm using here. Starting is 1, 2, 3, 4, 5, 6, 7, 8. And highest 1, 2, 3, 4, 5, 6, 7, 8. Is the first octet value. For class A, first bit 0 is reserved. So for class A, this first bit should be 0. So I'm making this bit as a 0 actually. So to differentiate that, I'm using another color. So first bit I'm making was 0 actually. That's it. So first bit 0 is reserved. That's all.
Sir, can you repeat?
Yeah, first bit 0 is reserved for class A. Now convert to decimal language. All zeros value what? 0. All ones value. Example is also 1. Then all ones value is what? 255. But the first bit we made is 0, right? Means what is the first bit value?
120.
128. So minus 128. You'll get it is 127. That's 127. So 0 to 127 for first octet. Second octet, 0. Third octet, 0. Fourth octet, 0. In highest second octet, 255 dot 255 dot 255. It's a class A. Okay. Yeah. So class A range is 000 to 127.255.255.255. It's clear, everyone?
Yes, sir.
Do you want to repeat one more example?
One more example, sir.
Okay. See, I'm
One
just
more example.
using, yeah, sure. I'm using only starting minimum and maximum addresses. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Then tell me, which class IP address do you want to repeat? We'll do which class IP address calculation? B or C or D or E? Tell me. Class B. Okay. So for class B, priority bits. So which bits are reserved for priority bits?
First two.
1, 0. So first two bits should be 1, 0. So first two bits should be what? 1, 0. So first two bits I'm making as it's a 1, it should be 0. It's a 1, it should be 0. That's all. Done. Now convert it to decimal. First bit is 1 bits. What is the first bit value?
28.
128.
That's it.
So 128. Now if all are ones, example is also 1, then total ones. Value is what?
Yes.
255.
Minus
But actually here second bit is 0 now. So which is 64 is 0. So you do minus 64. You'll get
90.
Okay.
or 91. So 128 to 191. 128 to 191. For first octet, second octet 0.0.0. Highest second octet 255 dot 255 dot 255. So class B range. So 128.0.02 191 255 255 255 is a class B range. Similarly, you try to calculate and quickly tell me the answers for class C range, class D range, and class E range. Do it fast.
1.
So class C, priority bits are 110. For class D, priority bits are 1110. For class E, 1111. Yeah, please do it.
Class C, sir, 192.223.
Class D is 1224 to 239,
Okay,
or class E 240 to 255.
okay. Okay. So class C range 192.0.0.0 to 223.0.0 255.255.255. Class D range 224.000 to 239, 255, 255, 255. Finally, class E range 240.0.0.0 to 255, right? 255 dot 255 dot 255 dot 255. So based upon these ranges, now we can identify which IPs belongs to which class. If any IP starting with, if any IP between 190 to 223 is a class C. In IP between 224 to 239 is a class D. Correct? So these are the ranges of IP address. Any doubts? Right. Then, so try to identify first IP addresses belongs to which class.
A class.
A. Okay. Next 192.16,
C
3.1.
class. C class.
Class C. 192 is a class C. 10.00.27.
A class.
Class A. Again 192, 168,
Class
29.1.
C. Class C.
Class C. 169, 254. Class B. 200, 234. 200 means it's a class C. 172, 168, 23, 45. It's a class
B.
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 Correct. 10, 0,
A.
122, 122 is a class A.
A.
182,
Class
182.18,
B.
B.
class B. Right. Again, 192, 168, 23, 23,
B.
C.
class C. 192 means class C actually. 202, up to 223,
C.
class C.
C. C. Sorry. C.
223, class
D.
C. 223. Okay, next
Class
245,
C.
Class D.
Class C.
class E. So this IP address, which is 245.234.12.68. So this IP address can be used for LAN and WAN? No, we cannot
Oh.
use. This IP address is reserved for research and development. We cannot use it
R&D.
actually.
R&D.
Yes. Next IP address 224.9.8.192 is a class
D.
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 At least can we use this IP address for your local computers and wide area computers?
No.
No. It's for multicasting. So what
Yeah.
is multicast? I'll tell you in the some next sessions actually. Once routing is begin, then you can come to know where to use, how to use multicast IP addresses. Okay. But we cannot use this multicast IP address means class D and class E for LAN and WAN. So LAN and WAN, there are A, B, C classes are IPs are reserved. Last example. So this IPS belongs
Class
to
C.
which class? Class?
Class C.
Class?
Class C.
Class?
Class C.
Class? Tell me guys. Sure? That's invalid.
There's two, three, four.
It's
Yeah. It's invalid actually.
256. So 256, is it valid? What is the maximum combination?
55.
255
255.
only. Then how 256 will come in the picture? So it means you are seeing only first octet and telling class. You are not reading the complete IP address. I'm true?
And time check.
But you are not reading, man. So that is why you're telling this is a class C. You're seeing the first octet and telling the class C. So the thing is, first read the complete IP address and identify whether it is valid or not. Then later you can identify the class action. Okay. So this type of tricky questions also will come in the examination section. All right. So again, a quick task you have. Quickly give the answers. Identifying class. First IP address belongs to
Class A.
A. Next,
Class B.
192. Class C, 192.
Class
Next, 224.
Class
224.0010.
D.
Class D.
D.
Next, 120.200. Class A.
Class A.
Next, 150.
Class
Class
B.
B. Last one.
Class A.
A.
Invalid. Invalid, sir. Invalid.
Again, you cannot
Invalid.
explain. Just now explained
Invalid.
actually. It's an invalid IP address. 256
Yes.
is there, right? All right. So next logic is device 1, device 2, device 3, device 4, device 5, device 6. Like 2 or more devices are interconnected. What we call this is
Network.
a network.
Yes.
So to enable communication between these devices, we must assign IP address. Correct?
Yes.
Then which class IP address do you recommend to use for this
Class
computer?
C.
A or
To
B
see.
or C
Class C
or
only.
D or E?
Class C.
You can use A or you can use B or you can use C, correct?
Yes.
Yes. Correct.
We cannot use D also, cannot use U or E. So ABC only can use. Again, my question is from ABC, which class is recommended? A or B or C?
Sir,
C.
only.
Why?
So we need to avoid the waste of IP.
So
Why?
Only
how many devices are connected here?
6 only.
A device in a network called host.
Host.
A device
Yes.
in a network called what? Host.
Host.
So IPv4 address is divided into network
and host.
and host.
Host bits.
So based upon your requirement, we need to use A or B or C. For class A, first octet is network portion.
Network remaining host.
Second octet is host.
Host.
Third octet host. Fourth octet host. For class B addresses, first octet is network.
Network.
Second octet is network.
We have host.
Host. Host. For class C, first octet is network. Network portion and host portion. Correct. Now, based on our requirement, if your requirement is more networks if you need, then you can go for class C. Or if your requirement is very few hosts, you can use class C. Requirement is very more number of hosts, then you class A, like that.
Network.
So if you take one service provider, Geo, ISP, network is one, but how many customers are connected to Geo?
Many.
Many customers. Means we need
Class
more number of hosts. So which class IP address is recommended? Class A.
A class.
Like if you go with some banking sectors, which is the largest bank in India, State Bank of India. So this is one network is okay, but how many branches, how many equipment, how many devices? Many, the large enterprises network. So which class IP address is recommended?
Class A.
Class A. Railways, network is one, but devices can be millions. Class A. What about your home network?
Class C.
So at your home, how many devices maximum will be there? 5 to 10 devices.
10.
Let's say 5 to 10 devices. So means very few, very less number of hosts you need. So which class is recommended?
C.
Class A. So class A IP start with 192. That is why we are very famous. We are very familiar with 192, 168 IP address because we are connected to home networks. Actually. Correct?
Yeah.
So based upon our network requirement, host requirement, we can use A or B or C. For example, my requirement is I need networks are 110 networks I need. Which class IP address to recommend?
C.
Class
C.
C. Why class C?
256
So 255.
to one
It's
result.
not like that actually. See, the
254 we
thinking
can
is
The
more
replace.
requirement
network.
of number of networks is more, sir. We need to
Yeah.
go class.
2 की power n
See,
sir, the host
we
bit is
know
1.
that more networks are available in class A, right?
Yeah.
Know that what? More networks. But how many? How many networks? What is the exact number? Tell me what is the exact number?
2 की
How
power
many
n
networks are
minus
available?
1. Power n minus 1, I think, sir.
255, 255.
That we don't know.
2,
You're just assuming that, right? 255, 255. We are assuming that.
sir, 2 power n minus 1, sir.
Okay. So we need to calculate it actually. My requirement is networks 110. So 110 networks can I get in class A or class B or class C? We don't know that. We know only portion. First octet is network portion. First 2 octets are network portion. First 3 octets are network portion. But we don't know how many exactly numbers. Agree? Let me explain that. Actually. First octet, how many bits?
8.
Second octet,
8.
third octet, fourth octet. So total number of network bits in class A, 8 bits. Total number of host bits in class A. Total number of host bits, 8 plus 8 plus 8. Total
24.
24. Total number of network bits in class B.
16, 16.
Number of network bits are 16. Number of host bits are
16.
60. Total number of network bits in class C,
24.
24.
Yeah.
Total number of host bits,
8.
8. Is it clear, everyone?
Yes, sir.
Now we need to calculate for number of
Host.
networks.
Okay.
So for number of networks to calculate, we have one formula which is 2 power
And
number of network bits, 2 power number of network bits minus
1. Priority.
priority bits, 2 power number of network bits minus priority bit. You just remember this formula. Okay. Now let's start for each and every class. Let's start with class A. For class A, implement the formula as it is. 2 power number of network bits. How many number of network bits of class A?
8 minus 1.
8 minus. How many priority bits for class A?
1.
Priority bits for class A. Remember?
1, sir. 1.
1. For class B,
2.
2 bits. For class C,
3.
3 bits because 1 1 0. For class C, 1 0. Class A 0. So 1 bit,
1,
2
sir.
bits, 3 bits. So 2 power 8 minus 1. 2 power 7. 2 power 7 value
128.
128 networks are available in class A. What is my requirement? 110. So can I use class A? Yes. So 128 networks are available in class A actually. But all 128 networks are not used. There are 2 networks are minus here actually. So in class A, how many networks we can use?
26.
126. Then you can ask me question. Why minus 2? So because class A range is 0 dot 0 dot 0 dot 0 1 dot 0 dot 0 2 0 0 0 3 0 0 like that's 127 dot 0 dot 0. So 0 to 127 is a class A range, right? The first one, which is 0 0 0, this is reserved as a global ID. Global ID. So means all 4.3 billion IP addresses are used. All 4.3 billion IP addresses are reserved for identified by global ID. 00 indicates 4.3 billion IP addresses. So we cannot use this global ID for computers. Similarly, 127 network is also minus. So this 127 network is reserved for loopback ID. The loopback ID is to test purposes is to test TCP IP stack. So two networks are minus, one for global ID, one for loopback ID. Between 1 to 126 networks we can use. Got it? Rafi, it's clear? Okay. And class B. Anyone, can you please open the mobile calculator and do some quick calculations? Tell me answers. Open your mobile calculator. So class B,
minus
2 power number of network bits. 2 power number of network bits are
16 minus 2.
16. Priority bits are 2. So what is the value of 2 power 14? 16384, right, Kaushik? 16384 networks are available, but no minus 2. Kaushik, have you done minus 2 or same value, 16384?
I have done -2, 2 power
No,
14.
then it is
No, sir. I didn't do
16386.
-4, sorry.
82.
382.
No, minus 2 actually. 2 power 14 is 16384, right?
Yes, sir.
Then 16384 networks are valid. No minus 2 here. Minus 2 only class A.
Okay, sir.
Okay. So global ID, loopback ID in only class A. That's it. It's just finish. In class B, 2 power 40 networks are used. In class C, full networks are used actually. See about class C calculation. For class C, two power number of network bits are 24 minus priority bit are 3. That's 2 power 21. 2 power 21 value
20
20
97
20
7152.
152.
2097152. 2097152. Thank you. So these many networks are available. So based on a requirement, you can use any class. 126 networks are in A, 16384, 20971. So we have a clear number. So how many networks are in A and B and C? Like how many hosts are available in A, how many hosts are available in B and C also need to be calculated. So we just calculate number of networks. We'll continue with number of host calculation. Number of hosts. Number of host formula will be 2 power number of host bits. 2 power number of host bits, base minus 2, not power minus 2, base minus 2. Means every network there are 2 IPs are minus here actually. I'll tell you why. Let's start with class C. So for class C, implement formula, same formula here. 2 power number of host bits. How many host bits?
8.
2 power 8 base minus 2. So what is the value of 2 power 8?
120. 256.
256
Minus
minus 2. 254. Actually, 256 IPs are available, but 2 IPs are minus. So how many we can use?
254.
254. So we can say 254 are valid hosts per network. For each network, how many networks are in class C? 2097,152 networks. For each network, there are 254 IPs are available actually. Okay. Next, for class B. Class B, 2 power number of host bits 16 base minus 2. So 2 power 16, 65,536 minus 2 in 65,534. What is 65,534 what?
Networks. We need
Valid
two sets.
hosts per network.
Yeah.
So total are 65,536, but 2 IPs are minus. So how many we can use? 65,534 valid host per network. Like class A, 2 power 24, 2 power 24 base minus 2. So 2 power 24, 16 millions, 777, 216 minus 2, correct?
Right.
16, 777, 214 valid host per network. So based on our requirement, if we have 10 computers, 20 computers, 150 computers, 200 computers, go with the class C. If you have 500 computers, class B, 1000 computers, class B, 10,000, 20,000, class B, have millions of devices, class A. Like, clear? But why here for every network minus 2? Number of network calculation we minus in class A only. One for global ID, one for loopback ID. But in number of host calculation, we are doing minus 2 for every class. Means every network there are 2 IPs are minus. Here minus 2, here minus 2, here minus 2. Why?
So broadcast IP and one.
Correct. Network ID and broadcast ID. If you take example for class A, 10 dot 0 dot 0 dot 0. See 10 dot 0 dot 0 dot 0. What will be the immediate next IP address? Next immediate IP address?
One.
Is it 10 dot
0
1 dot 0 dot 0 or 10 dot 0 dot 0 dot
0
1?
1. This one, sir.
This one is valid.
Right, sir.
Like what is IP format? How to write IP addresses? Example, if it is brand new vehicle, what is the reading will be there? Brand new vehicle. All zeros. You write 5 kilometers. Where number will change? In right side, left side?
Left hand side, sir.
Here number will change, right?
Yes.
So 5 kilometers number will change. Or if number changing here, then 5,000 kilometers. Actually, we ride only 5 kilometers now here. So after 15 kilometers, 1 5, where number will change? In first portion, or second portion, or third portion? Here number will change, 15. So means when this value will come, once it's complete 9 maximum. So for 10 will come here, change is 10. 19, here 20. Like this. So when it comes to 99, now you can change here it actually 100. So this is the direction. Same like this IPv4 address also. 10 dot 0 dot 0 dot 1. 10 0 0 2. 10 0 0 3 4 5 up to
250.
10 0 0 255. So maximum we reach 255. Next third octet will change, right? 10 dot 0 dot 1 dot 0. Like 10 dot 0 dot 1 dot 1. So maximum need to be reached. Then it will be 10.0.2.0, 3.0, 4.0. So 10.255.255. Next 10.1 dot will come, right? Means second octet will be changed. 10.1.0.0. So finally we can reach to 10.255, 255.255. This is completely 10 dot network range. 10.0.0.0 to 10.255. In between, we have 16 million 777,216 IPs total. Agree? Out of 16 million 216, 777,216, two IPs are minused. The first one, 10.0.0, this we call network ID. This is only for identification. Means 10.1 can identify by 10.0.0, 10.2 IP address, 10.3 IP address, 10.4 IP address. Between all IP addresses, identify by only one ID called network ID. The last one, 10.255, also it is not usable for a computer. This is broadcasting purpose. Broadcast ID we call them. So network IDs, broadcast are minused. In between, means network ID broadcasted in between IP addresses we call usable IP address, or we call valid IP addresses. So only valid IP addresses we can use for a computer section. Like in between, how many usable IP addresses? It's actually 16,777,216 minus 2. Why minus 2? One for network ID and for broadcast ID. So we can use 16,777,214 IP addresses. Got it? Yeah. So 10.2.9.8. This IP address will be identified by which network ID? What will be the network ID of this IP address?
10.0.0.
10.0.0.0 is the network ID. Then broadcast ID 10.255.255.255. Okay. Tell me 182.16.9.8. What will be the network ID of this IP address? 192.0.0.0. Wrong.
127, sir. 120. Oh, sorry, 128.0.0.0.
Yeah, 182.0.0 is wrong. So first, before identifying network ID and broadcast ID, first identify these IPs belongs to which class?
Yes.
Which class IP address it is?
Class B.
Class B. Tell me network ID and network portion, host portion. First octet is network.
Network.
Second octet is network.
Host.
Third octet,
Host.
host, host. So how to identify network ID and broadcast ID means very simple logic, guys. In host portions, if you write zeros in host portion and 255 in host portion, that's all. Zeros in host portion is network ID. 255 in host portion is broadcast ID. Don't change network portion. Write as it is. 182.16.0.0 is the network ID. 182.16.255.255 is the broadcast ID. In between IPs are valid IP addresses. How many? Actually, there are 65,536. Two IPs are minus. One for network ID, one for broadcast ID. So 65,534 IPs we can use actually. Clear? All of you clear?
Yes, sir.
Then tell me 192.168.8.9 network ID and broadcast ID.
192.168.8.0 to
192.168.0.0 is the network ID. Correct?
no, sir.
No. Why?
Wait. So there is 3 network bits.
Excellent. So it's a class C. Then it will be 3 octets are network portion.
Yes.
Broadcast ID
192.168.8.225. 255.
yes. So it's a network ID and it is broadcast ID. In between all IP addresses we call valid IP address. Clear?
Yes.
Network address, IP address with all bits as zeros in host portion. In host portion, zeros is network ID. Once in host portion is broadcast ID. Valid IP addresses lie between network address and broadcast address. Only valid IP addresses are assigned to host and clients. We cannot use network ID and broadcast. Clear?
Yes.
If you have any doubts, let me
Sir, one thing, sir.
know. Okay.
Sir, in each classes, I think first time minusing that broadcast IP and network ID. But here I seen that in each classes, suppose 192 we picked, 190, 192 series we picked. So in 192 series, every time we are minusing that 192, 168, 6 dot, suppose I started with 0 and then I reached to 256, so 255. Then I need to minus that 2 IPs every time, sir.
For every class, there are two. But it is the formula itself is telling is right.
Yeah, sir. But yeah, in this, sir, you say 192, 168, 8.0. But it is started from 192, 192 to 255.255, right, sir?
No, I didn't get you.
See, sir, 192 is the starting range of the class C,
Yes.
and up to 223. So
Yes.
that will be the last, means first value we need to minus 192.0.0.02 uh 223.255.255.255.
Correct.
These two we need to minus, sir, right? Or in each series, suppose
In each series, -2.
in each series, sir.
Yes.
Suppose I took 193. So
193 also -2. 194 also -2.
okay,
Per network, every network, two IPs are minused for network ID and broadcast ID.
great, sir.
Yeah. Okay. Yeah. No doubts. Say 192.168.8.0. Is it valid IP? Is it valid or not?
Yes, sir.
192.168.8.0. Can we use this IP address? No, it's a network ID,
8.0.
right?
No, sir. 8.0 we cannot use.
So what will be the first valid IP address? What will be the
8.1,
first
sir.
usable IP address?
8.1, that is.
192.168.8.1 is the
1.
first usable IP address. So remember this logic. First usable IP mostly we use for a gateway address, means default gateway address as
Yes,
a
sir.
router
Right.
IP.
Yes, sir. Right.
So in class B example, what will be the first valid IP address? 182.16.0.1.
1.
Here 10.0.0.1. So mostly first usable IP address.
Gateways
It
or
is not a
routers.
rule actually, but recommended. There
Yes.
is no rule first valid IP address only for router. It's not like that. It's a rule actually. Okay. See, this is your task. Identifying valid IP address. So try to identify valid IP address. First one, 119.1.1.1. Is it
Class
valid
A.
IP? Not class. I'm asking
Okay.
about
Valid, sir. Valid.
valid. Okay. Answer is yes. Next one,
Yes.
yes or no? 170.17.255.255. Is it valid IP? Yes or no?
No, sir. No, sir.
No. Why?
Sir, 255.255 last bit.
Okay.
And that is the broadcast ID in
It's a
class B.
broadcast ID. It is not
Yes.
valid IP. Correct.
Broadcast ID.
Next.
This one also no.
11.1.0.0.
No,
It's
sir.
not valid.
My God. 11.2.9.8. Tell me network ID for this IP address. 11.0.0.0 is a network ID.
Yes.
11.255.255.255 is a broadcast ID, correct?
You're right, sir.
In between,
All are usable.
means what about 11.1.0.0? In between, you can come now.
Yes,
Ah,
valid,
yes.
Is it valid or not?
valid.
Valid, sir. Valid. Right, right.
So if here is all say 0, if it is 11.00, then it is network ID.
And
Here
yes.
11.100. So it's a usable address. Answer is
Yes.
yes. Next, 195.255.0.255.
Hmm.
No, zero.
No, it's a
No,
broadcast.
no, sir. Broadcast.
Last one, 142.10.00.
B. So no, sir. Not.
No, it's a network ID.
Yes, sir.
So these are all the logics we need to keep in mind, guys, when you're working with the IPv4 address. These all the logics are important actually. Okay. Yeah. No doubts.
Hello, sir. I have one doubt about the WhatsApp group. You said that on the first day of class, you you will be making a WhatsApp group for this batch.
I didn't hear you. Can you repeat? Your voice is too low.
Sir, on the first day of the class, you said that you are making a WhatsApp group for this batch.
Correct.
Yes, sir.
We'll do it. We'll do it. I'll do it. Okay. I'll create and tomorrow I'll share the link. Okay.
Okay, sir.
Yeah. Okay. All right. So it's all about for today, and still few more logics need to be discussed in IPv4. So tomorrow we'll continue with that logics and continued by IPv6 also.
Okay, right.
Thank you guys. Yeah. Have a good day.
Thank you, sir.
Thank you.
Hello, sir. Can you hear me, sir?